Number 3, show by suitable net ionic equations that each of the following species can act as a Bronsted-Lowry acid, and then we have letter B. So in this case, we have to show how HCl will act as a Bronsted-Lowry acid, key in on the acid component, with a net ionic equation. So I wrote down here a little trick for you guys, describing what they want. Now, in this case, if we're acting as a Bronsted-Lowry acid, Bronsted-Lowry are just the two scientists that, invented this idea about acids and bases and what they do. So if you're starting off as an acid, the acid has to go on the left-hand side. So in this case, they told us that, HCl was the acid. And since we're dealing with the net ionic equation, you have to write down the states. And HCl is going to be aqueous. All your acids and bases, they're going to be aqueous. There might be an exception, but it's pretty safe to say that they're going to be aqueous. Now, in the meantime, let's just write out this double arrow. Double arrow means that it's in equilibrium, right? We went over equilibrium in the last chapter. But now here's the thing. The one thing that's constant is that if you have an acid on the left side, you're always going to be adding a H plus on the right side. So that's standard. So HCl will break up into something plus H plus. And that's aqueous as well. So if you can see here, that here was the H, and now it broke off, right? It broke off into H plus. Basically, the break was right here. Now we just got to figure out what the base was. Well, in order to find the conjugate base, and conjugate just means that it's on the product side, there's two things that you have to do. The first thing is you got to lose one H from the compound. But since there was only one H and you lost it, you now just have Cl. The second thing that you're going to do is minus 1 to the charge that you saw in the beginning. But when I look here, there was no charge. So what was that charge? That was a 0. So coming over here, 0 minus 1, because that's what you do when you convert from acid to base, always minus 1. 0 minus 1 is a negative 1. You could say negative, you could say negative 1, that's fine with me. And since we're dealing with acids and bases, that's chlorine with a AQ. And now, if we want to cross our T's and dot our I's, right, we should notice that HCl was a strong acid. HCl is part of our strong acid list. Remember, there's 6 total strong acids and 6 total strong bases. If you have a strong acid, which is what HCl is, it will not be in equilibrium. It will dissociate 100%, meaning that there will basically be none more of this. And the yield sign would be just a general yield, because you shouldn't really be having this at the end. It will all be, majoritively, will just be your ions. And now we are done with the problem. And this is your balanced equation, your net ionic equation. And there you go. Hopefully this helped. Let me know in the comments, subscribe to the channel. Thank you so much for viewing the video, and I really hope this helped. All right, I'll see you later for part C. Stay tuned. Bye-bye.